Let's begin. First, let's talk about the basics of exponents, just in case we've forgotten. This is strictly an Algebra 1 review session. Although when you did this in Algebra 1, you probably did it over 3 or 4 days. We're just going to do it one day. And we're going to be using a lot of this in all of our sections in Chapter 6. So we know that 3 to the second equals 9. That means 3 times 3. 3 to the 1 equals 3. Anything to the 1 power is just itself. And you see this pattern. You can follow it. Okay. It divides by 3 every time. So that leads us to 3 to the 0 power, which must equal, if you follow the pattern, 1. Yeah. So if you follow the pattern, if you just make up an answer, a lot of people say 0. So don't do that. Understand there's a bigger system here. And that what you are not doing is that you are not multiplying times the exponent. I know some people say, well, 3 times 1 is 3. That's why it's 3 to the 1 equals 3. That's not correct. Because then they say, well, 3 times 0 is 0. Not correct. Okay? So there's a pattern here. Every exponent that has a base of 3, answer will be a multiple of 3. It has to be. Because it's just multiplying 3's many, many times. So, of course, it has to be a multiple. And 0 is not a multiple of 3. And if we continue this pattern, 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1 divided by 3, 1/3. And divide that by 3, you get 1/9. So if 3 to the positive 2 equals 9, 3 to the negative 2 equals 1/9. 3 to the 1 equals 3. 3 to the negative 1 is 1/3. So there's a big idea here, and that is that negative exponents equal positive fractions. Look at all the answers on the right here. They're all positive. It doesn't matter positive, negative exponent. The answers are positive fractions or decimal. So when you see negative exponents, we're not talking about negative numbers. Not talking about negative numbers. When is this negative exponents used? You mostly see it in science, like in biology especially, when you're talking about things that are very small, the size of a molecule, the size of an atom. You see things written like this. 3.82 times 10 to the negative 15. This is not a negative number. That is equal to what? 3, no, what is it? It's 0 point, and then 15 zeros, right? And then finally you get to 382. It's saying like this is like the width of a human hair, or this is the size of, a cell, or something like that. So negative exponents are used for very, very small numbers. That's what they mean. That's what they're for. And you can also use, positive exponents. You can talk about, 93, quadrillion miles away is this planet. So for real big distances, you can use positive exponents. So it's much easier, though, to write a number like this and putting calculations in a calculator like this, as opposed to making sure you actually put in exactly 15 zeros before hitting 382. So a lot of it's just to avoid mistakes in arithmetic. All right, and let's see here. So anything else? I think that's it. What's the purpose of all negative exponents? We see a pattern in negative exponents. All the answers are always going to be a multiple of whatever the base is. Your answer is going to be a multiple of that. So 1 can go into 3, 3 can go into 3, 3 and 9, 1/3 and 3, 1/9 and 3. They have to have the same numbers. All right, good. Let's see here. Anything else? Yeah. So So we'll be looking at some basic problems like this. Remember, these are just shortcuts and shorthands for, instead of saying, well, n to the 3 is, we have 3 n's, and n to the second is, we have 2 n's. How many n's do you have altogether? Well, we have 5 n's. So instead of actually writing it out, n times n times n times n, and then having to count them all up, we can know without doing that, that we just add them together. So when you're multiplying, you just add up the exponents. The same thing here. 3 to the 4th we could say is 3 times 3 times 3 times 3, which is 81. And 3 to the 3rd is 3 times 3 times 3, which is 27. 81 times 27 is going to be the same as 3 to the 7th. 1, 2, 3, 4, 5, 6, 7. So, adding the exponents, not too bad. Do note that they have to be the same base. So it means they have to be the same variable, or they have to be the same number. So if this is 3 to the 4 and 2 to the 4, it doesn't work. It has to be the same base, or the same variable. Okay. Another shorthand, for n to the 3rd to the 2nd, it's kind of like saying, well, take n to the 3rd 2 times. You're doing this 2 times, so it really means 3 n's and 3 more n's, which is the same as just multiplying the 2 exponents together. It's called power to a power. So anytime you see 2 powers together, there's a power on the inside and a power on the outside, that's when you multiply them together. Some people like to put parentheses around the powers, and that way that it reminds them with, like, regular parentheses, that this means multiply. So if you want to put a parenthesis around it, that might help you that, well, this is when you multiply, and this is when you add. When you have 2 bases, that's when you add. So what's the mathematics involved here? That's adding and multiplying, stuff that you learned in the 4th grade. So what's the algebra that you need to know on this? It's when to use each rule. Anybody can say, if I gave you 10 of these types of problems, everybody get 100% correct. And if I gave you 10 of these types of problems, you get them all correct. The question is that if they're mixed up, some you have to add, some you have to multiply, would you know when to use the proper rule? That's where the difficulty lies. It's not the rule itself, it's just that when you have so many things going on, can you use the right one? So it's about recognizing and saying, okay, 2 bases, that's when I have to add. Parentheses, okay, when I have 2 exponents right next to each other, that's when I multiply. It's coming up with those types of rules in your mind, so you use the right rule at the right time. All right, let's see here. All right, a little bit of practice. I'm not going to do all of these, but just a few. The first 2 are just the first rule we're adding. The second 2 are where we have to use the power of the power, because there's exponents on the inside and outside. Number 5 is using both of them at the same time. So when you have to start deciding, first I have to add these, then I have to multiply this, then I have to add this again, that kind of thing. All right. All right, so my recommendation is do numbers first, then do each variable one by one. So I'm going to find out what 7 times 2 is. I'm going to do what a to the 1st times a to the 2nd is. Okay. So remember, if there's no exponent, it's automatically a 1. So this is 1a. There's 2 more here. Altogether you have 3. And then there's no other b here, so it just stays the same, b. Okay, number 2. If we did this, same thing, we just do...
This is now me.
Okay.
That was Mom, 10,
Okay.
I don't know. this now.
Okay. Josh. Alright. So we do the go down. Do this -3 first. Do the variables alphabetically. So do the k's. Then you do the x's. So piece by piece, just break it up into smaller pieces. All right. Number 3. Longhand, this means -4x squared times y times -4x squared y. That's what it means longhand. We're going to try to avoid writing it all out and doing it the long way. Instead, we're going to say that this is -4 to the 1. This is y to the 1. So we multiply. We got an exponent on the inside and outside. That's when you multiply it. It's kind of like distributive property. So we have -4 to the 2, x to the 4, and y to the 2. Notice I use parentheses here. So for the numbers, use parentheses. So 16, x to the 4th, y to the 2nd. And if you're ever not sure on these, you can always just do the long way. Alright, just write it out. -4x, like this. You can say, okay, -4 times -4, that's 16. X to the 2nd. Okay, x to that's, might be easier to see. You just write out the long way. Okay. All right, number 4. Take a look at this. Let's see here. We got to multiply here, here, and here. So I get 2a to the 6th, b to the 9th, and c to the 15th. Is that good? What's wrong? Yeah. So this is a common mistake that I see is that, well, the things that have the exponents, that's what I multiply by. But even if it does not have an exponent, you still have to multiply it. So if it doesn't have an exponent, put a 1 there, and then you'll not forget about it, okay? You won't forget about it. So it's really going to be 2 to the 3rd. What is 2 to the 3rd equal? Don't say 6. Thank you. It's a shame, after all this work and doing everything, some people say, oh, 2 to the 3rd is 2 times 3rd, which is 6. It's 2 times 2 times 2. All right, that's 2 to the 3rd. 4 times 2, that's 8. So let's not make these small mistakes. All right, and 5 is when we actually put it all together. We'll do some more practice actually on the homework, so we'll skip this for now. All right, let's talk about negative exponents. Here's the big idea. A negative exponent on the top of a fraction is a positive exponent on the bottom. So it really just switches from negative to positive when you move it around. You guys saw that on the first page that 3 to the -2 was equal to 1 over 3 to the +2, which is 1/9. So if 3 squared is 9, 3 to the negative squared is 1/9. Same number, 9, just on the bottom. When you have a negative exponent, it moves it and makes it that small number, that small positive fraction. However, it does matter if you have parentheses or not. Here's something that might help you recall why things work the way they work. So if I had 3m, say, squared, okay, I told you that m equaled 2. How would you solve the one on the left? You would do this, right? And then what? Squared. Then you would do just this is squared, right? Just the m is being squared. The 3 is not being squared. Just the 2 here. So you get 12. Remember this? Like, so when we were doing like all those quadratics, right? And I said, well, find f of 1. You had to square it, then do the negative. So same thing here. We had to square it, then multiply by the number on the outside. Over here, it would just be 3 times 2 squared, which is 6 squared, which equals 36. You know, very, very different answer, with or without parentheses, right? So it's the same thing with the negative exponents. It's really being able to look at these two and say only the m is being squared here. But on this one, all of this is being squared. Okay? All of it's being squared. So when we look at these, we have to recognize, well, it's really 3 times, so really this is the only part that's being raised to the negative 2. So that's the only part that moves to the bottom. It's just that part. So we have now a 1 over m to the positive 2, which equals 3 over m squared. Only the m's being raised to negative 2, as opposed to over here, everything is being raised to negative 2, so everything moves. The 3, the m, and now that's being squared, which equals 1 over 9 m squared. Very different answers. Very different answers here. With and without parentheses. Alright, what about over here? It's negative m squared. Just think of it as a negative 1 times m to the negative 2. So we have negative 1 over m squared. As opposed to here where it's negative m squared. So it's positive. With and without parentheses make a difference. Ready? Okay. I think that's it. Okay. So what I'm going to do now is I'm going to pass out your homework. You're going to work on it for a little while. I'm going to go over a few questions, to see what your progress is, see how you're doing. And hopefully if you're making any small mistakes, we'll catch them now so you don't make them on the whole entire homework, but catch them in the beginning. And then I'll let you work a little bit more, and then we'll do, a few of those on the back that are a little bit longer. So first time we'll stop, we'll look at just the front. Second time we'll stop, we'll look at just the back. As always, you want to really focus on, when I leave here today before class is over, do I know how to at least start every single problem? You don't want to, get home and finally look at those last 3 on the back and say, oh, I don't get those. Oh, well, make sure you look at everything, so you at least know how to start everything before you leave. That way when you go home, it's more of a matter of just finishing it up and not worrying that you're going to have to get stuck or anything like that. Okay? Sounds good. So pass this out. Somebody, let's see, where are they? Yeah. There you go. Josh?
Am I designated now?
Yep.
Like the guy?
You're the guy.
I want it.
You can always designate somebody else.
All right,